César is from Fom Technologies, and he'll be telling us about the role of slotdie coating in photovoltaics. You have about 20 minutes. Good luck.
All right. I hope it's enough time. Thank you so much for sharing the stage with me and for the kind introduction. All right. So the title of this talk is the role of slot die coating in the future of photovoltaics. At first glance, it sounds a little bit dramatic, but I'll try to make a point. Uh, so we are FOM Technologies. We are a very small company with headquarters in Denmark, in Copenhagen, which is where I'm located at the moment. FOM originally stands for Functional Organic Materials. So it all starts with the discovery and then later granting of the Nobel Prize of the organic photovoltaics, organic photoactive effect in the year 2000. Fast forwarding 12 years, FOM was founded as a spin-off from DTU. Oh, okay. As a spin-off from DTU, as a commercial spin-off from DTU in 2012, and it was mainly targeting organic photovoltaics. So we basically built slow dicoders. A little bit later, between 2013 and 2017, we expanded a lot our customer base, and one of the strategic partnerships was with the University of Washington, which allow us to have a showroom and to establish really nice workshops that are still up to date if you're interested. Basically, accelerating technology for a lot of startups around the world and small companies that are deciding what to use for the coatings of the smart devices or thin film technologies. This is still ongoing. In 2018, there was a very crucial change of ownership and a new management appointed, which led to as a strategic decision to become an indexed a company, a uh, publicly indexed company, and we did this through Nasdaq Nord. And as a result, despite the pandemic in 2021, we perform as one of the best, one of the highest and more accelerated developing companies on Nasdaq. So because of that, and we have a lot of different customers. We apply our technology to different uh, types of interests, and we have a very nice selective academic customer base, including a lot of most of the highest rated universities in the world. Also, some corporate customers, the ones that we can disclose in the PV industry or batteries. But what is slow die coating? And slow die coating is a method to coat a wet film uniformly across a moving substrate. So the way this works is that you have a pump reservoir that drives an ink through a metallic structure. This is called a slot die. And then this slot die metallic structure has a small groove which conveys the high pressure, the ink from the reservoir into a meniscus guide, and it makes a contact with the moving substrate to a meniscus, to the meniscus formation. This leads to the forming of a wet film that is very uniform. In this way, the largest the slot die, the largest the area that you will be coating. And here I initially had a very interesting video, but since I cannot include videos in this presentation, I have a small time lapse of a printed area. This is around what you see here on the right hand side is around 30 centimeters being coated, 30 times 30 centimeters being coated in around 16 seconds. So this is an example of what you can do. Of course, printed or slot dies of up to 2 meters are commonly spotted in industry. This technology is a very simple, very primitive. Was discovered for the first time by Kodak in the UK in 1950. This was done as a strategy to evenly coat photographic chemicals into the paper. Now back to my talk. It is, to set the stage a little bit, I have to recall the first time I saw this plot that you see here, this I borrowed from a paper that I'm citing